Today we are going to study the ranking cycle. The cycle is a study under the vapor power cycle. The who has ranking? The first of all we discuss about the ranking cycle histology. The Williams Johns Macron ranking 5 July 1820 to 24 December 1872 was a Scottish mechanical engineer who also contributed to civil engineering, physics and mathematics. And he was a founding contributor with Rudolf Clausius and William Thomson, Lord Kelvin, to the science of thermodynamics, particularly focusing on the first of the three thermodynamic laws. Ranking cycle is named after him. Then, what is a ranking cycle? We today will discuss about the um, ranking cycle explanation. What is the ranking cycle works? The ranking cycle is a model that is used to predict the performance or efficiency of steam turbine system. It closely describes the process by which steam operated heat engines, commonly found in thermal power plants, generate power. The heat is supplied externally to a closed loop, which usually uses water as a working fluid, and it is a ideal cycle for vapor power plants and does not involve any internal irreversibilities. The first of all, we discuss about the block diagram of vapor power plant. This ranking cycle consists of four main parts: the boiler, turbine, condenser, and pump. And the first one is a pump which compresses the liquid. Second is the boiler or heat exchanger, and third is the turbine, and fourth is the condenser of heat exchanger. And these are the main important four parts are there for consisting of the four component. We can explain the ranking cycle. Then there are different types of processes involved in this case ranking cycle. The process from the TS diagram we can see that process 1 to 2, 2 to 3, 3 to 4 and 4 to 1. First of all, it is about the process 1 to 2. 1 to 2 isentropic compression in a pump, and then second 2 to 3 indicates constant pressure heat addition which is irreversible. Then 3 to 4 process isentropic expansion in turbine, and then 4 to 1 process is showing the constant pressure heat rejection in condenser, also reversible. Then discuss about the explanation of that one. What is happening from this given diagram? We can show that the condenser, pump, boiler, and turbine. The first of all, at state 1, the water enters the pump as a saturated liquid and is compressed isentropically to the operating pressure of the boiler. This is happening in the state 1, and then state 2, water enters the boiler as a compressed liquid, leaves as a saturated vapor at a state 3. That means the boiler nothing but the closed vessel with the steam is generated. Steam generation phenomena takes place in the boiler. This state 4, the superheated vapor enters the turbine where it expands isentropically and produces work by rotating the shaft connecting to a electrical generator. That means state 4, that the expansion of steam takes place. That the expansion process has been occur in the turbine. The then the pressure and temperature of the steam drops during the process to state 4 where it enters the condenser. After doing the work in the turbine, then the steam is enter into the condenser section. In condenser, what happens there? In condenser, you have to reject the heat and to the water. That is, the steam is heat is rejected by the steam and heat gained by the water. The steam is condensed at constant pressure in a condenser and leaves it as the saturated liquid. And these are the functions of the different components shown in this figure. And then discuss about the what is boiler. What is boiler? Boiler nothing but from the given diagram we can show it. The boiler is basically a large heat exchanger where the heat originating from combustion gases, nuclear reactor, etc., is transferred to the water essentially at constant pressure. And then we discuss about the energy analysis of ideal ranking cycle or efficiency of ranking cycle. Now, what are the energy phenomena takes place in the ranking cycle? What are the efficiency of the ranking cycle we discuss here? As all the four components with the ranking cycle are steady flow devices, thus all four that make ranking cycle can be analyzed as a steady flow process. The kinetic and potential energy changes of steam are usually very small relative to the heat and work terms, therefore they are neglected from steady flow equation. By the steady flow equation, Q minus W equal to delta H, and in process 1 to 2 pump Q equal to 0. That is W pump equal to S2 minus H1 equal to V in bracket P2 and P2 minus P1 bracket complete. Then for process 2 to 3 boiler W is 0, again the heat is entering, Q in equal to S3 minus S2, and then they discuss about the process 3 to 4 turbine, again Q is 0, W out equal to S3 minus H4. Then discuss about the process 4 to 1, consider again the work is 0, then Q out equal to H4 minus H1. Now we can find the thermal efficiency eta equal to W net upon Q in, as W net equal to Q in minus Q out. Then that means the efficiency equal to 1 minus Q out upon Q in. Then again you can do express in the another way, eta efficiency equal to 1 minus in bracket H4 minus H1 divided by S3 minus S2. That we can write down W net equal to Q in minus Q out equal to W out minus W in equal to in bracket S3 minus H4 minus S2 minus H1. Then discuss about the deviation of actual vapor power cycle from ideal one. The ideal actual vapor power cycle differs from ideal Rankine cycle, and this is due to the irreversibilities in the various components and causes of irreversibilities. And there are so many problems are created in the turbine section, boiler section, expansion section. There are different types of losses can be done, irreversibilities has been done. The main causes of irreversibilities are first for the fluid friction. The fluid friction nothing but it causes the pressure drop in the boiler. That means the pressure reduces, increases in the boiler section. The condenser, again the condenser, such type of phenomena occur, and the piping between the various components. As a result, the steam leaves the boiler at somewhat lower pressure, and also the pressure at turbine inlet is lower than at a boiler exit due to the pressure drop in the connecting pipes. That means the pressure loss, pressure drop takes place in the different section of the um, um, components of in Rankine cycle. Then discuss about the heat losses. The heat losses means heat losses are second major reason for irreducibilities in the vapor power plants. They are caused due to the heat loss from the steam to the surrounding as heat flow through the various components. Again, the heat losses take the different section of the Rankine cycle. That means the compensation for the losses due to irreversibility. So first one, compensate from the pressure drop due to fluid friction. We usually pump the water at sufficiently higher pressure than the ideal Rankine cycle calls for in the boiler. The second point, for the heat losses during the flow of steam, we supply more heat to the steam in the boiler to maintain the same net work output and compensate for heat losses. They discuss about how to increase the efficiency of the Rankine cycle. Then discuss about the how to increase the efficiency of Rankine cycle. The first one, the basic idea behind all the modifications do done to increase the thermal efficiency of vapor power cycle is to increase the average temperature at which heat is transferred to the working fluid in the boiler, or to decrease the average temperature at which heat is rejected from the working fluid in the condenser. The second point, the average fluid temperature should be as high as possible during heat addition and as low as possible during the heat rejection. Then we can discuss about some methods to increase the efficiency. The first one, lowering the condenser pressure. Second is the superheating the steam to the high temperature, and third, increasing the boiler pressure. The first of all, we discuss about lowering the condenser pressure. The lowering of the operating pressure of the condenser lowers the temperature of steam, and thus temperature at which the heat is rejected gets lowered. Then second one, superheating the steam to high temperature. Superheating the steam increases the net work and the heat input, as a result of which the overall thermal efficiency of cycle increases. They discuss about the third point, increasing the boiler pressure. The increasing boiler pressure raises the saturation temperature of the working fluid, which results increase in the temperature at which the heat is transferred to the working fluid. They discuss about some other modifications to the Rankine cycle. First one is the reheating and another is the regenerating. That means the word in In case of reheating, the reheating of steam in several or more than one stage is called reheating in vapor power cycle, which gives the generation to reheat ideal Rankine cycle. And second is the regeneration. Regeneration in case of regeneration, use regenerator to heat up the liquid, that is the feed water, leaving the pump before sending it to the boiler. Therefore, increase the average temperature, that is efficiency, during heat addition in the boiler, and this is called regenerative ranking cycle. And this is the end of the today's session. That is the today we'll discuss about the ranking cycle, the different components, and what are the erosities, what are the heat losses takes place, and this is the belong to the or overall belong to the ranking cycle.